This video is going to be from some questions from your quiz from Unit 5. And I want to look at questions 3, 4, 5, and 6 because they can all be solved using your graphing calculator. I have borrowed some of my new calculators that graph in color. So for this video, if you see a blue graph, that means it's a derivative graph. A green graph means it's the second derivative graph. Starting with question 3, you are given the derivative and asked to find where you have a horizontal tangent and determine if that's maximum or minimum on the original. So I'm going to take my derivative for number 3 and I'm going to graph it. Zoom 6 is a good window for number 3. And a horizontal tangent means the derivative equals 0. There are two places where the derivative equals 0. It looks like between 1 and 2 and between -1 and -2. Algebraically, if you set the derivative equal to 0, those two zeros are square root of 2 and negative square root of 2. To determine if these are maximums or minimums, again, this is the derivative graph. So before negative square root of 2, you were decreasing. After, you're increasing. That creates a minimum. Same idea here. So for number 3, you have 2 minimums, square root of 2 and negative square root of 2. Question 4, find the x-coordinate of each point of inflection. Point of inflection is a second derivative place, and it's where the concavity changes. So it's anywhere you go from positive quadrant to negative quadrant or vice versa. Number 4, here is the second derivative. And I made my window the domain they asked me to, so that's 0 to 2 pi. And I'm looking for anywhere I have change. So it looks like I have change a little past 3, and that place is pi, 3.14 pi. So number 4, you have a point of inflection at pi, and they only want the x-coordinate. All right, question 5 is back to first derivative. I'm going to change my color back to blue. So question 5, you have a first derivative and you are told a window to use. And they are wanting to know where on the original do you have decreasing. So anywhere that you are in a negative quadrant on the derivative graph, the original is decreasing. This is a multiple choice question. The only point in the choices where you're in a negative quadrant on this graph is choice C. So for example, choice A at negative 0.5, over here you are in a positive quadrant. Okay, if you try all the choices, the only one that works is C. And then question 6, I have a second derivative graph. And I'm wanting to know where is the original concave up. So anywhere on the second derivative graph that you're in a positive quadrant, the original is concave up. So I'm in a positive quadrant from where x is 0 on. I guess not including 0. That makes number 6, choice B.